Let's go over the solutions to quadratic functions, parabolas, exercises. So first up, we want to find the vertex and the axis of symmetry of the following function. We'll start with 4x squared minus 6x plus 13. So the shape of this graph is a parabola. This one's going to be an open parabola opening upwards, or better known as a smiley face parabola, and the vertex is going to be at the very bottom. Now, because this is opening upwards, it's going to go up forever, so there's no maximum, but right here at the bottom of the U, where the vertex is, that's going to be your minimum value. Now remember, parabolas are symmetrical, which means you can draw an imaginary line right through that vertex, and what's on the left-hand side and the right-hand side exactly mirror one another. That imaginary vertical line is called the axis of symmetry. So to find the vertex, use the formula that the x value will be negative b divided by 2a. Remember, a is the number in front of the square term, and b is the number in front of the singular term. So that's going to give me negative 6 divided by 2a. The double negative will become a positive, and this will reduce to 3 over 4. So that's the x value of the vertex. Now the y value we can find by plugging 3/4 back into this original function. So 4 times 3/4 squared minus 6 times 3/4 plus 13 to get 43/4. So this ordered pair right here at the bottom of the parabola, the very minimum value, is the ordered pair 3/4, 43/4. Now the axis of symmetry comes straight through that point, and the axis of symmetry is a vertical line. A vertical line is x equals a number, so no matter where you are on that vertical line, it's never going to change. Well, since it goes through the vertex, and we know that x value is 3/4, the axis of symmetry is that vertical line, x equals 3/4. Let's do another one. Let's find the axis of symmetry in the vertex of 2x minus 1 times x plus 3. Now, of course, this is not in that nice standard form, ax squared plus bx plus c, so what we'll need to do is distribute. Everybody in the first group will need to get multiplied to everybody in the second group and combine like terms to see that this is really 2x squared plus 5x minus 3. We can now find the vertex by finding that x value, negative b over 2a, and we get negative 5/4. So that's the x value of our vertex. To find the y value, we'll plug in negative 5/4 into this original function here. And you can plug it into this form right here if you want to. These are the same. I just went ahead and plugged it into this original form. 2 times negative 5/4 minus 1 times negative 5/4 plus 3. And when I do that, that ends up giving me negative 49 over 8. So the vertex is the ordered pair negative 5/4, comma negative 49/8. And the axis of symmetry is the vertical line x equals negative 5/4. Let's look at an application problem. The daily profit from the sale of x units of a product is given by P of x equals 24x minus 0.2x squared minus $100. What level of production will maximize the profit, and what is the maximum possible profit? Well, let's look at this. Notice that the highest power here is a square, so that tells us when we graph it, it's going to be a parabola. In front of the x squared, the a value is negative 0.2. That means we're going to have a frowny face parabola. With a frowny face parabola, the vertex is up top here. There is no minimum because it goes down in both directions forever, but the maximum is right here. So when you see a question like this, asking for the maximum profit and the maximum of a frowny face parabola, it's asking for that vertex. So we can find the x value by having negative b over 2a. So negative b is going to be 24 over 2 times a is that negative 0.2, which gives us 60. So that x is, notice that x is the number of units. So what level of production will maximize the profit? 60 units. So this means that 60 units will need to be produced and sold to get your maximum profit. What is that maximum profit going to be? To find out, well, we know it'll happen at 60 units. We can plug 60 into our profit function to see that the maximum profit is going to be $620. Okay, let's find the vertex and the zeros. Remember what zeros are. Those are the x values where the function is equal to 0 of this function here, and then we'll graph it. So the vertex is going to be negative b over 2a, so negative 6 over 2 times negative 2, which gives me 3/2. So that's the x value of the vertex. Now what do we know? A is negative, so this is going to be a frowny face parabola, so we're looking for this maximum point up here. It's going to happen when x equals 3/2. When we plug 3/2 into the original function, we'll get our y value, which is going to be 25/2. So this point right here, this vertex, the maximum point on this frowny face parabola is the ordered pair 3/2, 25/2. Now we can find the zeros, and when we find the zeros, we'll set the function equal to 0. We will have to factor. I'll go ahead and factor out a -2, and then this will factor into your x minus 4 and your x plus 1. Set the factors that have a variable equal to 0, and my zeros are going to be 4 and -1. Well, these are the x values that make the function equal to 0. So if the function is equal to 0, that means the y value is equal to 0. So that also tells us that the ordered pair 4, 0 and -1, 0 are your x-intercepts. So now what we have are 3 ordered pairs that we know for a factor on this frowny face parabola. We have the vertex 3/2, 25/2, and we have the 2 x-intercepts 4, 0 and -1, 0. So because we know those are on there, we can graph those points and then connect them with that frowny face parabola. So here's that -1, 0, 4, 0, and that vertex 3/2, 25/2. And then you can go ahead and just graph that frowny face parabola going right through those 3 points, knowing that this maximum value here, this is the turning point where your function goes from increasing to decreasing. All right, and the last thing we're going to talk about is that average rate of change. So remember, the average rate of change is the slope of the secant line. It's the straight line that connects those 2 points on the curve. So if I wanted to find the average rate of change of g of x equals 3 minus 4x minus x squared from x equals -2 to x equals 1, I'm looking for the slope of the secant line, the line that connects the 2 points when x is -2 to x equals 1. So from our previous notes, we know that we're going to take g of b, or g of our second point, minus g of a, or g of our first point, over b minus a, or our second point, minus our first point. It's really just finding the slope, the y from your second point minus the y from your first point over the x from your second point minus the x from your first point, realizing that the y values come from the function evaluation. So we will plug in 1, we'll call this x1 and x2, so we'll plug in 1, 3 minus 4 times 1 minus 1 squared, minus, then we'll plug in -2, 3 minus 4 times -2 minus -2 squared, all over 1 minus -2. So we can simplify this. We get 3 minus 4 minus 1 for g at x2, minus 3 plus 8 plus 4 for g of x1, and then we end up getting -2 minus 7 over 3, which gives us -9 over 3, or -3. So the average rate of change, the average change rate at which this function is changing from -2 to 1 is -3. So maybe, depending on what this function is measuring, maybe it's going down $3, maybe the cost is going down $3 per shirt, or maybe you're losing 3 pounds per month, or whatever it is decreasing at a rate of 3, whatever the units would be measured by. That's it for now. See you next time.